Okay, so then welcome once again. This is another episode. Today I want to talk about indices, and today we'll be talking about the first three laws of indices and some properties of indices. Let's dive in. So when we talk of indices is another way of writing numbers. Indices is another way of what? Writing numbers. So this is a typical form how an indices looks like. With indices, we have this small n we see here. We call it the index. We call it the index, and the plural of index gave us that indices. So when we talk of indices, it's all talking about those exponents and stuff. And another name for this is what? Exponent. And I know most of you have heard of this. And the last name for this is power. And the big A you see here, that's what we call the base. So indices is all about bases and exponent. So indices is just another form of what? Writing numbers. So when I have, let's say, 2 to the power 4, the 4 you see here is telling me how many of the base should I multiply together. The 4 you see here tells you how many of the base should I multiply together. So it means that this 4 is telling me that I should multiply to the base 4 of the base. So it will be 2 times 2 times 2 times 2. So that is the meaning of the index or the exponent or the power you see over here. So with certain numbers, we can write them in index form. For example, 8, I can write 8 in the index form, which is 2 to the power 3. When I multiply 2 times 2 times 2, 3 of them, I'm getting 8. So some numbers, you can write them in their index form. That's the simplest what? Index form. Good. So now, let's talk about the laws. Indices have laws. Let's talk about the laws of indices, how indices work with these 3 laws I'm about to explain. So, the first law of indices says, that when you have 2 expressions or 2 terms multiplying, again, take note, when the terms are what? Multiplying, and the bases look the same. So as you from here, you can see the bases, both of them are AA. And the operation there is multiplication. What you have to do is just to add the exponents. You just have to add the exponents. Are we okay? So no matter the number of terms you are going to get, provided the bases are what? The same. So you can have, let's say, numerically, 2 to the power 3 times 2 to the power 2 times, let's say, 2 to the power 4. So this time we are having 3 terms. Do not say the Lord didn't give us 3 terms, so it's not true. Just check, are they multiplying? Is the basis the same? If yes, maintain one of the base, then add the exponent. And with this we are getting 2 to the power 9. So that's what the first law is saying. So now let's go to the second law. The second law also says that when you have, again, 2 bases and there is a division sign, you have to do what? The opposite of the first one. So you realize that multiplication goes with addition, division goes with what? Subtraction. So take note, you see that link. Multiplication mostly goes with addition, division will go with what? Subtraction. So over here it means when the bases are the same and the sign is division, you are going to do what? You are going to subtract. Are we okay? So the last law I'll talk about, which is the third law, says that when you have a to the power 3 in a bracket and then another one here, make sure this is not, the 2 is not the exponent of 3. That one you cannot multiply. But when you have, let's say, a to the power 3 and that bracket is to the power 2, If you want to move out of the bracket, you just have to multiply these two exponents. So it becomes a to the power 6. A to the power 6. You just have to multiply. You just have to multiply. So in general, we say when you have a to the power m or to the power n, for you to come out of the bracket, you have to multiply, which will give you mn. Are we okay? Are we okay? So now let's also talk about some of the properties of indices. Let's talk about some of the properties. So with this principle or the laws that have been given to you, plus the properties, will guide you in solving any question under indices. Will guide you whenever you are solving any question under indices. So some of the properties, these are properties and they have been proven to be true. So whenever you meet them, do not just apply them. So the first property I'll talk about is any number to the power 0. Any number, anything to the power 0 in indices, we say is equal to 1. Is equal to 1. Anything to the power 0 is equal to 1. So if you have, let's say, 100 to the power 0 is equal to 1. 1,000 to the power 0 is equal to 1. 4 to the power 0 is equal to 1. Anything to the power 0 is equal to 1. The next property I'll talk about, I call it the power of product of two numbers. The power of product of two numbers. So with this one, I said if you have two expressions, let's say a and b in a bracket, and they are all raised to the power n. And if you want to move out of the bracket, you have to make sure you distribute this power to each of them. Distribute this power to each of them. So it means that our a will carry the n sum, and then our b2 will carry the what? N sum. So numerically, if I have, let's say, 2 times 3 all to the power 2, and I want to move out, I make sure 2 will carry the 2 times the 3, 2 will carry what? The 2. That's what this property is also saying. And the next property, I call it the negative index. The negative index, when you have a to the power negative n, this one can be written as 1 over a to the power n. This one can be written as 1 over a to the power n, and vice versa, and vice versa. So if I have, let's say, a to the power negative 2, I can write it as 1 over a squared. 1 over a squared, and vice versa. You can also write this one in the form of this. So take note. So take note. And the third one I'll talk about is the power of quotient of two numbers properties. So this property also say that when I have these two numbers, so just as we did for multiplication, when they were in a bracket and we decided to come out, we have to distribute the same thing here. The same thing here. Make sure if you want to remove the brackets, because they are all raised to a common power. Before you move out, make sure you distribute this n to each of them. So we get a to the power n, b to the power what? N. That's how we deal with it. And the next one I also talk about is the negative power of quotient of two numbers. The negative power of quotient. So if I have this quotient a to the power b to a negative power, and if I want to make this power positive, you don't do anything big. If you want to make this power positive, just flip it or reciprocate the quotient, reciprocate the fraction. Just turn it upside down. Automatically your power becomes positive. So turning this upside becomes b over a, all to the power positive n. Just turn it upside down. Okay, so the fourth one, I think I've said a lot. So the last one I'll talk about is the fractional index. How many of you are aware that the square root of any number in indices can also be written as a to the power half? The square root of any can, and then the third root can also be written a to the power 1 over 3. The fourth root can be written as a to the power 1 over 4. That's another property. So in indices, when you have square and you are solving square root, and you are solving any number under indices and you don't know what to do, you have to change it to an index form by raising it to the power half, or depending on the roots you are dealing with. Okay guys, thank you for watching, and then see you in our next video so we talk more about indices and solve more example. Thank you.